Hello, AP Chemistry, and welcome to a brief review on acids and bases. We talked about this part of acids and bases last year, right? But here we're just going to remind ourselves, right, that really we shouldn't need that because you remembered from the summer. But anyway, memorize me. Super, super important. One of those things that's going to happen all year long, right, is that we're going to talk about chemical reactions. And before you can analyze what's happening, you have to know which ones are strong acids versus weak acids, okay? For right now, the concept of weak acids is null. We're not going to talk about it yet. But they behave differently and they do different things than strong acids, which means it's super, super, super important that you memorize these now, right? Because this is all we have. That's the whole list of strong acids. Okay, not the whole list. There are a couple others, but these are the whole list of strong common acids, okay? Which means that when we get to the other chapter where we talk about weak acids, if it's not strong, it's weak, right? So these have to be memorized, right? Note that hydrofluoric is not on this list. When we get to the next 2 chapters from now, we're going to talk about why that's the case, right? But note that hydrofluoric acid not on the list of strong acids, right? We have our chlorate series like chlorate and perchlorate, right? Nitric and sulfuric. For bases, all it really is our soluble hydroxides, right? That's what's on this list, right? Group 1s, because all group 1s are soluble, right? And the bottom part of group 2, okay? So all of group 1 and the bottom of group 2. Those are our soluble hydroxides, and those serve as our strong bases. And again, have to memorize this, no way around it. All right, acids and bases from the microscopic point of view. So if we have HCl, aqueous, in a beaker, what's that going to look like? Right. It's going to look like this. And they're all going to be floating around like that because strong acids are also, ding, 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 strong electrolytes, meaning that they dissociate completely, right? When we say something's a strong electrolyte, it dissociates completely, right? Now, point of reference here, right? Let's say we had another beaker over here, right, that we weren't using. And this beaker, let's say, was filled with acetic acid. Hang on. Acetic acid, which we're going to write as HC2H3O2 for now. We're going to talk later about why 1H, by the way, why I don't really prefer this writing of this acetic acid. But so if I have this in water, is that one of my strong acids? No, acetic acid is not one of my strong acids. It is a weak acid, which means that it is a, ding, 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 weak electrolyte. And what does it mean if something is a weak electrolyte? Right, it dissociates some, not completely, but some. Meaning that if we were to do a particle representation of what's in this beaker, right, we would say that there are some H plus ions. We would say that there are some acetate ions, and we would say that there are some total things running around. Yes, as in we have ions separated and some all stuck together. Yes, some undissociated aqueous portions of it also. Yes, does that make sense? Which is different than here because we would not say this, right? If we wrote that, that would be inappropriate to describe the particle diagram of HCl because there aren't any that are stuck together. It's a strong electrolyte, dissociates completely. Yes? Fantastic. All right. Then that brings us to NaOH. What would NaOH aqueous look like? Right. We'd have Na ions floating around with OH ions in our solution. Right. Now, if we were to mix these two beakers together, what would we get? Right. We would get NaCl and H2O via a double displacement reaction. Fancy name for that is neutralization. Right. So, in here, what are we going to have floating around? Right. Na ions, chloride ions. What else? Right. Water molecules. Yes? Not ions. Water's not an ionic compound. That's what's going to be floating around in addition to any excess of these two things. Yes? Does that make sense? Okay, very good. Which, by the way, right, is why if we were going to write a net ionic for this, right, the net ionic would say H plus OH minus, my bad, gives us H2O liquid. Yes, in that these change, right? These are no longer ionic in this picture, which is why this is the net ionic equation for most strong acid reactions, strong acid, strong base reactions. All right, that's a quick overview of acids and bases to the depth that we need to understand them for right now. Thank you for listening. Be good, and I will see you guys soon. Bye.